All right, today we're jumping into a really provocative essay that's been making some serious waves everywhere from San Francisco to DC. It's called Situational Awareness, and it makes a pretty bold claim. The age of super intelligent AI, it isn't decades away, it's barreling right towards us and could be here before the end of this decade. So the author, Leopold Aschenbrenner, he starts us off right there, in the heart of Silicon Valley. He says that if you listen closely, the talk has changed. People aren't talking about billion-dollar data centers anymore. Now, they're planning for trillion-dollar ones. This isn't just hype, you know? This is a huge industrial mobilization. It's a scramble for chips and power on a scale we haven't seen in generations. And this all leads to the core thesis of the entire piece, the prediction that is just staggering. The idea is that we're on track to hit artificial general intelligence, AGI, by 2027. And from there, it's just a tiny hop to true superintelligence by 2030. And this isn't presented as some far-off science fiction, but as a direct result of the trends we are literally watching unfold right now. Okay, so how on earth do you get to a timeline that aggressive? Well, the logic comes down to a pretty simple idea, counting the OMs. OM, that just stands for orders of magnitude, and each OM represents a massive 10x increase in an AI's capability or the efficiency we use to train it. To really wrap your head around this prediction, you just have to look at the progress we've already seen. I mean, think about it. In just 4 years, AI went from what the author calls a preschooler, GPT-2, to a smart high schooler with GPT-4. One can barely string sentences together, the other can ace the bar exam and write amazing code. That wasn't just a small step, it was a gigantic leap in what we thought was possible. So what powered that huge leap? Well, it was basically 3 key things, all working together. First, just a crazy increase in raw compute power. Second, we got way smarter with our algorithms, which made training much more efficient. And third, something the author calls unhobbling. These are clever tricks that basically unlocked the AI's hidden potential and turned it into something incredibly useful, like ChatGPT. So here's the core of the whole argument. These same 3 trends, more compute, better algorithms, and new unhumbling techniques, they're all still in full swing. The investment, the research, it's all on track to give us another leap of that same preschooler to high schooler size by 2027. And that next leap, according to this essay, is what takes us straight to AGI. But, and this is a huge but, the progress doesn't just stop at human-level intelligence. The next phase is where things get really wild. It's called the intelligence explosion. This is the point where a decade of human progress could get squeezed into a single year. The theory behind it is this kind of recursive feedback loop. So step 1, you get AGI. Step 2, you don't just have one, you could have millions of digital copies of it, all working to automate AI research. These AI researchers then make breakthroughs that make themselves smarter, which lets them make even bigger breakthroughs, even faster. And the scale here is just, it's hard to even imagine. We're talking about the equivalent of over 100 million human researchers, all working around the clock at speeds we just can't comprehend. The end result of this crazy feedback loop isn't just a slightly smarter AI. It's a lightning-fast jump to a vastly superhuman intelligence. Now, a technological jump this fast and this profound, it's obviously not going to be simple. The essay lays out 3 massive, enormous hurdles we would have to face on the way to superintelligence. Challenge number 1 is just the raw industrial scale of it all. The numbers are just staggering. By 2030, a single AI training computer could cost over $1 trillion and need more than 20% of all the electricity currently used in the US. I mean, we're talking about building power plants and data centers on a national scale. Okay, so the second huge challenge is security. When the code and the data you're working on are basically the recipe for the most powerful technology in human history, can you actually keep it safe? Can you stop it from being stolen? And look, this isn't some theoretical what if. This is a very real threat. Sophisticated nation-states have already proven they can get into just about anything, from nuclear programs to the source code of the biggest tech companies in the world. The secrets to AGI would instantly become the #1 target for every spy agency on the planet. The third challenge might be the most difficult of all. It's the alignment problem. See, our current ways of controlling AI, things like reinforcement learning from human feedback, they work because a human can check the AI's work. But That whole method completely falls apart when the AI starts coming up with ideas and plans that are so complex no human can even understand them, let alone tell if they're good or bad. So that leaves us staring at this fundamental and so far totally unsolved technical problem. How do you reliably control an intelligence that is just vastly superior to your own? If we get that wrong, the consequences could be catastrophic. So, given these three enormous challenges, the industrial scale, the security nightmare, and the alignment puzzle, the essay argues that our current path of just letting private startups figure this out, well, it's totally unsustainable. And this leads to what he calls the inevitable endgame, the project. The author is really blunt about it. He says, and I quote, "I find it an insane proposition that the US government will let a random SF startup develop superintelligence. The implication is that a technology this powerful, with such huge national security consequences, can't be left in private hands." So the solution he proposes is the project. You should think of it as a government-led effort, something on the same scale as the Manhattan Project that built the atomic bomb. The whole point would be to bring the full power and authority of the government to manage the development, the security, and the safety of AGI. And the logic here is pretty straightforward. Superintelligence is the ultimate national security issue. Private companies, as good as they are, just can't defend against top-tier government spies. And, decisions this big probably shouldn't be made by a single CEO. They need some kind of democratic oversight. And finally, dealing with these huge safety risks requires a coordinated national effort, not just what makes sense for business. And all of this leaves us with one last really powerful question to think about. The people who are closest to this technology, the ones actually inventing and building it, they increasingly believe this future isn't just possible, but plausible. So the essay kind of forces us to ask ourselves, what if they're right? What does that world actually look like?